9 o'clock here in sunny Arizona, so do a quick sound check. If you can hit your raise hand button to make sure everyone can hear me, and we're rolling along here. Perfect. Thank you very much. All right, awesome. To get started, do a little bit of just kind of housekeeping measures. So first off, if you have any questions, there should be a question and answer box right there up in the left-hand corner. So feel free to answer questions anytime as we go through this webinar here today. And also too, I have Jai Musselman. He is our business development manager down in the Florida region, who's also on the call. So he's going to help me out today with the question and answer. So if you hear another voice chime in, that'll be him helping me out today as I try and stay focused on the webinar and then let you guys go. I'm also recording today's session, so for any of you who'd like a copy of this recording when we're done, please email me at the end and I can share that with you, and then you guys can get that to colleagues or any other staff members that didn't make it quite today. So with all that, I'm going to go ahead and get started. So this is the Landscape Lighting Codes and Guidelines and Techniques webinar, and I am Brian Qualls. I will be your host today. I want to thank everyone for hopping in and joining us today. I'm going to try and make this as exciting as I can. I know talking about codes can be a little daunting, but we'll do our best today. But a little bit about myself. I am actually a licensed landscape architect, have been for over 20 years. I am the National Business Development Manager for Unique Lighting, and I've been with the company just coming up on 9 years now. So I came over 9 years ago and have been kind of doing this type of work for the last couple of years. My experience ranges from custom residential all the way up to big roadway type projects. I worked on just about every project you can think of. So the reason why I bring that up is just to kind of let you know where I come from when it comes to teaching these classes. I come from a little bit different angle than others, and hopefully this will be beneficial for you. And let's go ahead and jump right through it. Here's a quick snapshot of our agenda today. So we're going to talk a little bit about the codes. We're going to do some guidelines and kind of rules of thumb for laying out a lighting system. We're going to talk about some lighting techniques, color changing LEDs, and then I got a page just on a few resources, kind of where I pull some of my information, and hopefully if you guys want to dig deeper from what I touched today, give you some opportunities to go through there. So let's talk about codes. Super exciting stuff here. Basically, whether you're aware of it or not, all low voltage lighting is covered under the National Electric Code. Before you go run out and buy a book, they're quite expensive. They're could be 150 bucks. I think I paid 120, 135 for mine. There's not very much in the National Electric Code that is specific for low voltage lighting. In fact, I think there's only really 2 pages in here. But it basically covers the basics of the installation rules, and then it's also the requirements for the equipment. So manufacturers like us, we've got to follow a lot of these National Electric Codes when we're building our fixtures or transformers and things like that. So most of the stuff we'll cover today, it's pretty simple. You may already know it. But as you get deeper, your local codes are rooted within the NEC, but they will supersede the NEC. So wherever you're designing or wherever you're installing, make sure you know the local codes, and they can be different from city to city. I mean, I'm here in Arizona, and codes are different between Tempe and Phoenix, and you got to know where you're at. We're going to talk a little bit about the dark sky ordinances a little bit as well, and those are kind of a little more in depth. They are different from city to city, and then we'll talk a little bit about the product listings as we go through. So out of the National Electric Code itself, the National Electric Code defines low voltage lighting as any systems that operate at 30 volts and less. So there's a lot of products out there, and kind of what has happened with the low voltage lighting systems is that 15 volts has kind of become the norm. When you're looking at transformers, you'll get up to a 15 volt max. There are others out there, and in fact, we have transformers on the market now. We're coming out with some new transformers that are going to go all the way up to about 24 volts. And this is how those are allowed, because under the National Electric Code, anything under 30 volts is still considered low voltage lighting. So you can have a 24-volt outlet or secondary lead, and we use that. We'll talk about that a little bit more, but we use that for the longer run. So that way, when you're calculating for voltage drop, you can still have 12 volts at the fixture. Wire for low voltage can be direct burial wire. I get this question a lot. You do not have to put it in conduit, you know, but as long as the wire is rated to be buried. So you can't just go buy any wire off the shelf and put it in the ground. It's got to be UF rated. You know, the stuff that's got to have a little bit of a UV inhibitor in it is always recommended as well. But you can bury it right in the ground, and it needs to be buried at a minimum 6 inches deep and then 24 inches deep under driveways and sidewalks. So again, that's the National Electric Code. I would make sure that, you know, you follow your local code. Sometimes, you know, they're different. I know I've run into situations where when it's, you know, UV rated wire, you don't have to put it in conduit at all. But I know some cities, if it's above ground, they require you to put it in conduit. You know, and sometimes if it's underneath a hardscape like a driveway or a pathway, they do want it in the sleeve. I recommend you put anything underneath a hardscape in the sleeve, but really follow the local codes. Also, the National Electric Code will set the max amp load for wires. So even though manufacturers will give you, you know, what their max amp rating is, there is what we call a D rating. So there is a level that you can't exceed or you shouldn't exceed if you're going to follow National Electric Code. And then the last one here is that trunk lines cannot have an amp rating smaller than the transformer unless that wire is fused. So basically what that is saying is that, oops, what's happening here? Oops, sorry, a little technical difficulties. So basically what that is saying is that if your transformer has a 25 amp rating, you can't use a wire that only has a 20 or even a 16 amp rating unless you fuse that wire. Now that's part of the National Electric Code. So I know there's a lot of contractors out there that have been designing systems because quote unquote it's LED and they're putting a 14 gauge wire, you know, or even the 16 gauge wire to run their systems. Well, if that wire does not have a fuse on it, chances are you're violating the National Electric Code, because most of the transformers out there either have a 15 amp or a 20 amp or a 25 amp rating inside of it. And if your wire has a smaller amp rating than the transformer, that wire will actually burn up if there is a short. It's not just going to burn up, but if there is a short, that will burn up before the transformer has an opportunity to trip its breaker. So if you're using a wire smaller than the breaker on the transformer, you need to put a fuse on that wire, or use a wire that's rated for the same at the same amp rating as the transformer that you're using. So maximum amp rating per wire. So here is kind of what the manufacturer rating are. So, you know, 12 gauge is the most popular right now. So the manufacturer says it's rated at 25 amps. But really, when you derate it down, the max amps per National Electric Code should be around 16. Now, that number changes a little bit depending on where you're at in the world, and let me show you how I got there. So there is a kind of a correction factor that is included in there based on the Fahrenheit or based on the degrees of where you're located at in the world. So as I mentioned earlier, I'm in Arizona, so you know, I probably could go down to this rating here to 105, 113 range. But we, you know, generally we run our lights at night where it's a little bit cooler. And so this is where I get the 16 amp rating. So this is inside the National Electric Code as you go through it, and that's kind of where we're at. So as you can see, National Electric Code has identified that the temperature, your ambient temperature where you're using, has a direct effect on what the capacity of that wire can hold. So here's the example I was talking about, the trunk line rule. So if your transformer is maxed at 25 amps and your 12 gauge wire is, as we just discussed, is maxed out at 16 amps, I need to make sure I've got a fuse in the line right there. I've seen this too many times that I can count where I've been out in the field. System's been in the ground for a long, long time, and suddenly all the wires right here at this location are burning up, and then I'll get the question of, well, why didn't your transformer trip? Well, that's because the wire burnt before I could get to the max amp rating. So to save that, this is where we put the fuse, and then we got to size that fuse per the load. So you want to have no more than a 16 amp on the wire. If you've only got, let's say, 10 amps out here in the field, then maybe I only want to put a 10 amp fuse on that wire. So that way I'm making sure that I am catching that short if it happens out in the field. Local codes and highlights. The difficult part about the local codes is I could spend the next 10 years trying to figure out every single code for every single location and still not get them done. And oftentimes what I've run into, and I've done this in several parts of the country, they're pretty vague, and to the point to where you don't really know exactly what you're to do until someone tells you can't do it. I know it's kind of tough, but the biggest issue that I've run into is that if you're putting this on a set of plans, if this is getting reviewed, oftentimes the cities don't know who should be reviewing it. So the landscape reviewer is saying, well, no, this is electricity, so the electrical planners need to review it. The electrical planners are saying, oh, no, this is low voltage, the landscape guys have to review it, and then you're kind of stuck in limbo. And there have been times I've actually had to make phone calls to get someone to go through and review it and check it out. So sometimes it makes sense to kind of make your plans a little bit vague, or where it's at, to you kind of get through it, or you may have to pick up the phone and kind of push that through. Generally, if you follow the NEC, which is again that 6-inch depth, and making sure your amp ratings are matching with your transformers, you should be covered. You're going to get more stuck on the night sky stuff on the low voltage than you will with the local codes. So even if there are codes out there, try and do your best to follow them, and ask for them, but it's going to be hit or miss when you're out there on the local side of it. Now, as far as ratings, there are 3 different testing agencies out there, and it's really dependent on the manufacturer of who they kind of go with. Now, they all tend to follow the same rules. Probably the UL or the ETL are the 2 most that you've seen, and when you're done with this webinar, you can certainly walk around your house and take a look at just about anything you plug into the wall that you bought from Target or even Home Depot. There'll be one of these listings listed on the side. I bring this up because it's extremely important that when you're speccing or installing products, that you do find one, because it is talking about just the products being tested for safety. There's a lot of product these days that's coming overseas, it's coming on the internet that may or may not have been safety tested. And again, we say that this is low voltage, but at the end of the day, it's still electricity. So you really want to make sure you're using a quality product that has gone through testing. I can tell you from my experience and where I'm at, testing is expensive for the manufacturer. It is, and that is probably why some of these lesser expensive, overseas type stuff doesn't go through the proper testing. Because it does take time, it takes energy, and there's a possibility you don't pass. There have been times where we have submitted product that we've had to make some tweaks because we didn't pass the first time, and then you got to go back and tweak the product and get it to where it sets up and passes the rating. So you can't launch it until you have it. So that's the difference between kind of a NEC versus a ETL, UL, or TUV tested product. Now, NEC will say that anything you install needs to have one of these ratings before it is installed on a project. So we'll talk a little bit about the dark sky, night sky ordinances. This is the most nebulous one that's out there, and this is the one that I get the most questions on, and unfortunately, it's the most difficult to answer. It'd be easy to say, hey, what's the speed limit, right? The speed limit across the country is generally the same. It's either 55, 65, or 75, depending on where you're at. Dark sky and night sky ordinances, they are different. I've even seen them all the way down at the HOA level where they're pretty restrictive. And so the first thing you need to do is you need to go find if they have one. Be very careful when you ask, because once you ask, then you're stuck into it. And really the two things that you need to look at is, up until recently, it's always been discussed as a zero cutoff fixture. And what that meant is, if you've got your horizontal plane, no light is actually being directed above that horizontal plane. So as you can kind of see, I got the hat here is protecting on the shield and kind of shining down on the ground. Where a fixture like this, even at that little angle, wouldn't pass that zero cutoff layout, and especially this fixture here, because it's got an adjustable knuckle that I could even point this up even more and create a bigger problem. This fixture wouldn't pass. Now, the new rating that's out, it's called the bug rating, and the bug stands for backlight, uplight, and glare. It has been developed by the Illuminating Engineering Society and in coordination with International Dark Sky Association. And so there's nothing really implemented with this, but this is where they want you to follow. And if you kind of take a look at this picture, I got this from Moab. This is what they're talking about. So if this is a street light, you really don't want any of the backlights coming to the trespass on the back side of the fixture. So if you were to imagine if you had a house over here, or you were sitting in your yard over here, you wouldn't want to see any backlight from that fixture. The glare is similar to backlight, but it's kind of more prominent in the front side of it. And then the uplight is any light that passes, above that zero cutoff or that zero barrier. So the bug rating and a lot of the dark sky stuff really is written towards, and it's really geared towards street lights and line voltage type stuff. But unfortunately, there isn't anything pulled out for low voltage lighting. So you got to be real careful when you have that stuff, and sometimes it's best to get out in front of it. A couple of examples I can share with you is that I've got two situations. One where I was working in an HOA, and the homeowner used to be part of the board, and he had felt that he could just kind of steamroll his plan through. And I begged him and said, no, let's just go talk to the board, because they don't fully understand their dark sky. Let's see if we can get this through. So he said nope, he wanted to handle it. I helped him with the design, and backyard had 27 fixtures, I think, in the back, and we did everything, followed the rules. There was, very minimal uplight. We were lighting trees, a lot of wall washers, and we had a very, very nice design. By the time we got done with it, he went head to head with the HOA. He lost and ended up getting a design that had 11 path lights only, and it just did not lend itself to what he had, this beautiful backyard, and we got to put in 11 path lights. So my example to you is try and stay ahead of that, and try and work with the HOA or work with whoever wrote it. A lot of these times they don't get updated as you go through it, and then even when they do, I've had one situation where a landscape architect I work with, the plant came back and it was all redlined, and we wrote a letter saying, hey, look, we followed all your guidelines. We followed every single one of them. Don't let light pass property lines, and we had everything shielded and shrouded. And they went back and basically rewrote the entire dark sky ordinance to say 0 uplights allowed. So it gets kind of to be the Old West. So my challenge, or my advice to you is let's just try and don't fight it, and do your best to kind of work with it. One of the things that we've done in the past is we'll actually set up a demonstration kit at someone's location to kind of show whoever the governing board is that this isn't affecting the dark sky. We're not putting any glare out there. We're following the bug guidelines as closely as we can. It is low voltage, so we don't have a 1,800 lumen street light that we're dealing with. We're dealing with a 300, 400, or 500 lumen type fixture. So work with them the best you can, and do to get through it, because they can shut you down. They can shut your project down, and it becomes very, very frustrating. Okay, moving on from there, we'll go ahead and talk about how to lay out a system. So these are a lot of the questions that I get on projects all the time. I mean, basically, so how do I know what size transformer I need? How many transformers do I need? What's the longest run I can have? And then where is the best place to place a transformer? So we'll go through each of these here. The first thing is how do I know what size transformer I need? So what I tell a lot of newcomers that are trying to lay out a system, because a lot of people, they just don't know. They'll buy a bunch of lights and they'll just pick a transformer off the shelf that A, is either available in stock or B, that, you know, sounds pretty good because they just kind of, you know, that's the one that they have the most of. If you take a look at a transformer and you think of it as more of a bucket of watts, right? So if I've got a bucket or a pitcher of water that, you know, says, hey, if I was at your house and I said, hey, I've got 4 glasses or 3 glasses I need to fill, what size pitcher do I need? Well, that's hard to answer unless you know what size each of these glasses are that you're going to fill. So if I came back and said, okay, well, each of my glasses are now have 50 watts in there, as I run through it, I know that then from there I can, you know, how much of the transformer I can use. Now back to the National Electric Code, transformer can only be loaded to 80% of its capacity. So right then and there, you know, if I'm using a 300 watt transformer, I know right off the bat I can only use 240 watts of it. So I've got to have a little bit of water at the bottom of that pitcher, if you will, when I'm plugging in or pouring all the cups, you know, with my watts or using the fixtures as I go through. So then after I pour everything out, I'm coming out there and says, I know I need 150 watts. And so as that drains down, that means that I've only got 90 watts in return if I'm following the National Electric Code. So again, as what I do, and rather than you're sitting at the counter or if you're sitting there trying to figure out, okay, I got to go through and take my transformers 300, reduce it down, how many fixtures do I have? The easiest way to do it is what I call the 80-20 rule. So if you're buying a bunch or you're designing a bunch of fixtures out there and you add up all the watts, so 50, 100, 150, just add 20% to that total. And then whatever transformer you're going to use, reduce that by 80%. And then as long as you're in that range between adding the 20 and reducing, you know, 80, when you're at that point, that should give you plenty of room on your transformer when you're sizing it as you're going through. Now, there's ways to actually size it, and if you want to reach out to me, I can help you with that. I've got a voltage calculator that I use that will actually tell me exactly how many watts I'm using based on the design. But for a rule of thumb, I always use the 80-20 rule. The second question I have is, what is the longest wire run I can have? Usually I get this question on the concept stage, or, you know, on the side of the deal where I'm laying all my fixtures out and the electrical engineer needs to know where I want to put my power drops, or vice versa. I've only got certain power drops where I can put these transformers. What's the furthest I can run? And again, it all depends on distance and load, but here's kind of a quick little rule of thumb that you can use, is that if you took 40 watts, so basically, you know, 10 4-watt LEDs, the 4-watt LEDs is probably some of our most popular ones that are out there. If you were to put all those into a cluster, you know, put those into a hub type of deal, those 10 LEDs will drop 1 volt in 100 feet. So if I'm at 12 volts at the transformer, by the time I get 100 feet away, I'll be at 11 volts. Now, our LEDs, their minimum operating voltage is 10. So I can drop all the way down to 10 volts, and those fixtures will still operate. If I go below 10, they'll start to dim. So at 10 volts, they'll stay the same brightness as if they were at 12. So generally speaking, if I'm going to be using the 12-volt tap and I run 200 feet away, I'm still going to be at that 10 volts. So I usually keep my wire runs at the 200-foot max. Now, you know, a lot of our transformers actually have a 15-volt tap. So with that, you could say I'm plugging into the 14-volt tap, running 200 feet. I'm 12 volts at the fixtures, and then I know I've still got plenty of room for any type of dips or things throughout the day. Again, this is you know, we can sit down with you and help you figure out what the actual runs need to be and what your actual voltage drop is. But on the concept side, just trying to do something real quick on the fly, I would never go more than 200 feet away from any transformer using 12-gauge wire. One of the things that we need to talk about too is a volt amp. I'm not sure if any of you have heard this before. We've heard of watts, we've heard of volts, but there is also a terminology out there that's called a volt amp. And the volt amp is the measure of apparent power. Volt amps has always been out there. It's always been something that we've needed or that we've seen. It's just that when everything was halogen or when it was an incandescent, the volt amp is basically, it's a power factor. And on incandescent, on halogen, the power factor was always 1. And so 1 times whatever number it is, so if my watts were 50 times 1, I still have 50 watts. Well, now that we're running into LEDs, basically what's happening is the power factor has gone up. So our power factor, in general terms, is about 1.5, depending on the different LEDs and things that are out there. And that's the actual measure of the apparent power. The reason why I bring this up is even though you're buying a 4-watt or installing a 4-watt LED, that's the real power. That's what our customers, that's what our clients are getting measured on their electric bill. But as far as what the wire and the transformers see, is they see the apparent power, which is that 1.5 factor on the volt amp. And so we need to be sizing our transformers and our wires based on the volt amps and not so much on the watts. And so every manufacturer out there, including ourselves, we list what our volt amps are on all of our spec sheets. It's on our material, it's out there, and that's why that's there. So you can see our 5-watt LED, our par 36, actually pumps out 6.7 volt amps. So when you're sizing a transformer, and this is where that 80-20 rule comes in, is you need to make sure that, if you're adding them up yourself, you're adding up what your total usage based on the volt amps and not on the watts. Everyone's a little bit different. Some of our LEDs are a little bit more efficient than others, but again, that's that power factor or volt amp that we need to be looking at. And general rule of thumb is that if you can't find the volt amp, if you're using a manufacturer that doesn't publish this, then multiply your watts by 1.5, and that'll get you generally pretty close to where you need to be and to cover yourself as you're designing the system or installing the system. Lighting techniques. So I'm going to kind of talk real quick, and just these are general lighting techniques that I like to use when designing a system or installing a system. And you can see here the 3 things I'm going to talk about right now: your front lighting, cross lighting, and back lighting. So basically, front lighting or up lighting is exactly what it says. You're putting 1, 2, or 3 lights in front of a tree or an object, and you're shining up and creating a look like this. These are generally the fixtures that we like to use, a bullet light or even a kind of a bigger, this would be a par 36 or a well light. The problem when you're doing front lighting is that if you're only using 1 light per tree per se, and I see that a lot, is that you kind of start getting the hot spots and you don't really get a lot of depth. It really kind of gives it a real funky kind of look, and I have very little control when I'm only using 1 fixture. As compared to where I'm cross lighting or using 2 fixtures, you can see what's happening, especially on this palm tree right here in the front. I'm getting kind of that striping right down the middle, and that's because I've got the lights on either side. And what this is doing is it's kind of giving this tree a little bit more of a 3-dimensional effect. I'm getting a lot more texture, a lot more interest, a lot more highs and lows as we go through. As you can see, and I like to make this one, especially this picture here, because this is actually a very beautiful scene. Taking photos in the evening is difficult. So even though down here you might see some of these hot spots, that those may not be there with the cameras picking up, but it could also be from the viewpoint where we're standing. This light is kind of right there. If this was positioned a little bit differently, however, if you walk down this walk, you're changing that viewpoint, you probably wouldn't have that hot spot. But again, I'm a big fan. I really push minimum 2 lights per tree, so you really get this three-dimensional effect rather than spotlighting it. And this is a great point too, is that if I were to only light these trees on this side with 1 light all the way down, if you were walking back up this way up the walk, the back sides of all these trees would be completely dark. And from the viewpoint walking up this way would be different than the experience in viewpoint walking down that way. So again, that's why I kind of really like to push 2 lights per tree. Backlighting, this one doesn't get used as often as it should. And this is kind of one of my favorite techniques. And we did this here. This is actually a demo that we did out in the field. And I don't know if you can see that. It's kind of dark on my screen, but there is a hardscape edge right along here. So even if we wanted to try and front light these, we really couldn't. We didn't have the room. So we moved the lights to the back, so really puts these palm trees into a silhouette type of look. Gives us a lot of interest. But what it also does too, as you can see, is it's taking this rock wall in the back and bringing it forward. It's bringing it into the scene. Had I not done that and put these in front, that would have been completely dark in the back and we never would have seen that rock wall. Or we would have had to add more lights in the back to bring that through, and then now you're competing with the foreground and the background with all this light that it would make it look extremely flat. This way, it's giving it some dimension. It's a nice subtle look, not having to use as many fixtures, and gives us a really interesting kind of location by setting those back behind your shrubs instead of in front of them. And then downlighting. I'm a big fan of downlighting, especially out here in Arizona. I don't get too many opportunities to do it. We don't have these huge, giant, beautiful trees. You know, a lot of cactus out here. We've got big trees, but nothing like we do in the Midwest or down in the South. And as you can see, what we've done here is there's actually 3 lights up in this tree that are pointed down and lighting this area. What's nice about this is there's really no defined edge, so there's really no place to put any path lights or bollards. And you know, had we not done this, you know, over time the homeowner or property owner probably would have put a big spotlight right here and just glare bombed this whole thing, and would have just not been a comfortable space. So what's nice about this is I've got a nice comfortable atmosphere on the ground, and what we've done is we've put these at 5,000 Kelvin. So they're a lot cooler color temperature that gives me that silver moonlight, you know, on the ground. So this location here gets a full moon effect 365 days a year. And then path lights. If you've been to any of my other webinars, you know that I'm not a huge fan of path lights. And really not that they don't perform. As you can see, these are you know, they put out a great amount of light, and this is a really great scene. It's just that they become targets, right? They get hit by, you know, roller bags, line trimmers, extension cords, you know, garden hoses. And so when you are going to be using path lights, the best thing to do is make sure you're pulling them off the edges. Don't ever want to put them right in that corner there, because as we all know, someone in a rush or walking up here, they're going to walk and cut that corner if they've got a roller bag or something that they're trailing behind them. So we want to account for that by pulling these off the edges, or protecting them by something, whether it's a boulder or a shrub or something that gives them a little bit more protection, so that way someone's not going to try and cut this corner. So by turn, they're not going to cut that, you know, hit into that light. So again, you know, try and use as much ambient light as you can, but you know, like I said, in these situations here, you know, this is a perfect opportunity to be using path lights. Let's protect them. I'm not a big fan of putting lights in turf, so you know, if you have them out of there, that gives you, you know, I guess a really nice effect and protects them a little bit more. They'll still get hit, and we'll have to always maintain them, but it gives them a little more protection as you roll through. Step lighting. This is the one that I think kind of perplexes a lot of people that's out there, and what a lot of people like to run to is go get those step lights that they put right into each of the risers. Now, a situation like this, the last thing I want to do, this is a beautiful cut stone staircase, is try and now cut something to put in there. And so I think this is a wonderful example of how you can light a stairway without having to put those step lights in. For me, those step lights are kind of a last resort type of situation because, you know, not only would they break up something beautiful like this, but they tend to get kicked and, you know, toes kick them and they get beat up a little bit. So if I can light it any other way, I would, and I encourage you to do that. And you can see we probably needed another light here in this corner and maybe another one over there to light that. But this is still giving me a nice effect of being able to give me that destination, either, you know, going up or coming down the stairs. And as you can see, we've pulled them off the walks a little bit, kind of protected them a little bit with some shrubs and some bushes. And also here, same thing. If I've got walls that are on the perimeter that are bordering the steps, then I want to use any type of wall light I can, whether it's an undercap light or, you know, a Gemini type of deal. And again, I can get really nice look on this, and that's still without having to put those step lights up underneath. And I got a safe walk going up the stairs there. Now, the Voyager that we have, again, is a very nice light. It is pretty bulletproof. It's cast brass, so it will take a beating, but this will give you the look kind of as you're going up if this is something we can do. So you can see this is the perfect situation that I don't have the opportunity to put lights on either side. I can't put, you know, pass lights or anything, you know, through there that I'm stuck with putting these in the risers, and it's a very beautiful, very clean look. And here's the look from above. So you can see we did every other step to make sure you're consistent, so that way someone coming up, coming down, they don't get tripped up or anything. So either, you know, if you're going to do every one or every other one, but make sure you're consistent all the way through. But they put out a beautiful amount of light. That way it's a good safety walk as you're going up or down the stairs in the evening. Now we're going to talk a little bit about graze lighting. So graze lighting is probably one of the first things I do when doing a design or laying out a system. And basically what we're doing is we're taking that light and we're moving it as close to the wall as we can. Rather than pulling it back out here and trying to spotlight the wall, trying to push it as close as I can. What that does, it does two things for me. So the first thing is I really start to see the texture in the wall especially as we get, you know, kind of in the midpoint and you're running up. If we were to pull these fixtures back out here and spotlight it, the grains and the textures of this brick would almost disappear. It would go completely flat, and you wouldn't be able to see it. The second thing that this does is this gives me control of the windows. So again, now I can place these fixtures and get in between the windows rather than trying to spotlight it from the back. Because what the other benefit I get is, you know, I would venture to guess that 90% of the homes out there have some sort of sill. So that sill plate will help keep the glare from the light getting into the windows. So if someone's in here and there's a knock at the door, when they look out the window, they're not looking at a big spotlight in their face. They can see who's out front and then, you know, open the door from there. So that's an example of graze lighting. And here's another example. This is where you can take a very, very simple white stucco wall, and when you put the lights in the back like this and graze up the wall, you can see I'm now pulling out the texture of the wall, which is very, very nice. And then again, by putting on either side of the windows, I can control putting that window. The secondary benefit of this is now you can see that I put all these shrubs in a silhouette and gives it a very, very interesting look as you pull up to a house like this. As compared to trying to put one light in front of every one of these shrubs, I'm casting shadows on the wall, shadows inside the window, and then I'm not going to be able to get as high up second story with these fixtures. Again, I'm going to have to place more fixtures to get this look, and then again, I'm going to be competing foreground versus background. That again, two simple lights in the back makes this look very, very nice, and again, that's the graze. Again, put it right up against the wall and gives you that texture. So color, there's lots of options out there when you're talking color, and the biggest, hottest ticket right now is the red, green, blue color changing fixtures. Now, For me, it's tough to really kind of get into too much of that because as far as the red, green, blue, it's really a personal preference of what you want to do. It's seasonal, so holiday times, one color. We just had St. Patrick's Day, for green. If you've got when sports get going back again for your sports, whatever color you want. But the big thing that we jump into is what I call CCT, or correlated color temperature. And this is where you start hearing the discussions of 2700 Kelvin or 5000 Kelvin, or what is what when it goes through. So on the right there is a quick little scale to help you kind of see that the lower the number, so the 2700 Kelvin is that warm, almost yellowy light. And then as you go higher up the scale, it gets a wider light. So 5000 is a stark white, and then 6500 gets almost that blue, that silvery blue tint as we go through. Now, when for us at Unique Lighting, 2700 Kelvin is probably our most popular color temperature that we sell today. I've got several theories on why, and we could talk about that at a different time. But we're starting to see a trend where we're moving closer and closer into the 3000s, because the landscapes that we're lighting tend to look a lot better in the 3000 and even a little bit higher, 3500, 4000 Kelvin as you go through. So here's an example. If you're looking on the right side, you can see that we've clearly have 2700 Kelvin on the bottom, and this is actually 5000 on the top. And in the picture on the left, this is all 5000. And so the whites you can see are really affected by the color temperature, and even the blues. The blues here seem to be a little bit more muted than over here. And that's what we're finding. The 2700, the lower you are on that temperature scale, that tends to bring out the earth tones and the reds and browns and rust colors and those types of things really pop under the warmer temperatures of 2700K. As you move up the scale, 3000, 4000, that's where the greens and the blues really start to pop. And one of the things that I've been saying in my webinars lately is here in Arizona we've got a lot of green cactus, and I've got several guys that I know that I work with that are going, hey Brian, we're putting this green LED on this cactus, and boy doesn't it look great. And it to me it makes it look cartoonish. It's almost like taking a green colored pencil or a green crayon and coloring over the top of an already green cactus. Versus where you take a CCT where it's 3500 or 4000, it really brings the green out of the cactus versus me color splashing over the top of it. And if you go back to these pictures, you can kind of see what I'm talking about. So if you look at this tree up here in this corner, you can see on the 2700 how the browns are being highlighted a little bit in this tree. And this tree isn't dead; it's not even dry. But even though there's a little bit of brown in there, the 2700 is pulling that out. Versus over here at the 5000, those browns almost disappear, and now the green, vibrant colors are being pulled out. And that's what we're seeing in the landscape as we go through it. Now we've got a fixture out there or a bulb out there that you can actually color change from the Kelvins. It's our Vivid lamp 2700 or Vivid CCT, and it's a smart device from your Bluetooth from a smart device. So you can go from 2700 and with a slider bar slide it all the way up to 6500, anywhere in between. And what that does is it gives you the ability to then, rather than trying to pick a color in your head and say, okay, well, all these trees get 3000, all those trees get 3800, you can go to each lamp and slide that slider bar to a color position that just looks good to you or looks good to your client, which is more important, your client or your customer, of what color is comfortable for everybody. And once that's set, it stays that temperature until it's changed again. So even if we lose power or the lights go off, it will stay that temperature forever. So for those of you who are out there that are setting for your clients and you never want to tell them what you're doing, you can set that LED to that color and then be done with it, and then it'll never change ever again, and you'll have a nice beautiful looking scene when you're all done as you go through, and then no need to buy 5, 6, 8 different bulbs. It's all one bulb, fits in any fixture, and again, no special equipment comes with it. It's straight Bluetooth from any smart device right to that bulb. So that is the end of my presentation. I know we went really, really fast, but I wanted to make sure I left some time for some questions. So I'm going to kind of leave that open for now for the next couple of minutes. This is my contact information. Please feel free to send me any emails if you have any questions, if you can think of anything after we get off the line here, and then kind of put some resources here on the screen for you. So the first one there is if you do feel compelled to go out and get a National Electric Code book, and that's kind of the first code there. You can actually buy it at any Borders or bookstore that you want, or find it on Amazon if you feel compelled. I warn you, it reads like a manual, so it gets a little tough to read through it. Any information on the Dark Sky or Lumen Engineering Society, if you were worried about the dark sky stuff, and then of course our website there. So I'm going to stay on the line for another couple of minutes if there are any questions. Other than if not, then I thank you all for spending the morning with me, and hope everyone has a great week. All right, well, I'm not seeing any questions, so I'm going to go ahead and end the webinar here. And like I said, if anyone wants a copy of the recording, please email me, and I'll be happy to send you a link. Have a great week.